Hey everyone, welcome back to our Packet Tracer for CCNA End of Chapter Review Lab Review. How many times can I say review? A lot. So let's jump in with no further ado and take a look at Chapter 12's review. This is on spanning tree protocol. So we can see a sample topology here. We've got our PCs connected to a layer 2 switch. We've got some multi-layer switch devices in our topology, and we are told we need to run spanning tree mode rapid PVST on each of the switches to make sure they're running rapid PVST. Let's check out this layer 2 switch right here, and let's see what it's running, why don't we? So we're going to go to this switch and we're going to say, okay, access layer switch, show spanning tree, and I can pick a VLAN. How about the default VLAN 1? And look at that. It is reporting an IEEE spanning tree protocol status. What does that mean? It means that we are running classic spanning tree. Yeah, this is classic spanning tree 802.1d running on this device. So that's not going to do at all. We're going to go into global configuration mode and we're going to say spanning tree mode and we'll say rapid PVST. It's that simple. We'll end the configuration and we'll once again look at the spanning tree and see that we now have an RSTP designation. Look at this, they are converging now. These ports are reconverging. We have changed things, and so we just happen to catch a port in a listening state. Look at that. If I go ahead and run the command again, we can see it transition into the learning state, and yeah, this is great stuff. So we're gonna save our configuration on this device. Now, one of the things you may be curious about is, could we have a switch like this one running the rapid spanning tree protocol, that's 802.1w, could we have it running that and could it be interacting just fine with the other switches? And the answer is yes. But the bummer is, if we don't get everyone converted, all three of these switches converted, then we're not really going to be taking advantage of the increased speed, of the reduced latency. So we want to make sure that we get every device converted so that we can fully take advantage of rapid per VLAN spanning tree. On this distribution layer device, this multi-layer switch, let's do our show spanning tree for VLAN 1 and look at that. Even with this more sophisticated device, it is defaulting to the classic spanning tree protocol, and that's what we see there with IEEE. So once again, we'll just go into global configuration mode and we'll say spanning tree mode is going to be our rapid PVST. By the way, while we're here, what are other options? Well, just the per VLAN spanning tree mode, which would give us the IEEE, and the rapid PVST. So I'm going to end and I'm going to save. I don't think I verified that it took, so there's our verification. I'll save once more because I'm paranoid like that. And we will now go over to our final device. And this final device is distribution 2. And we're going to go ahead and say show spanning tree for VLAN 1. There it is in its default mode. We're going to say spanning tree mode is going to be rapid per VLAN spanning tree. And I will up arrow on the keyboard to verify that took effect. And I will go ahead and save my changes and close this window. And we have succeeded in step 1. Our 3 switches are now all running the rapid spanning tree protocol. What we're going to do now is we're going to set the root bridge, and we're going to do this for VLAN 10 using the spanning tree priority command. Now, let's have some fun here before we do that and see if we can figure out which of these devices is the root bridge. So I'm going to go to this distribution 1 device, and we're going to be manipulating VLAN 10. So let's go ahead and do show spanning tree VLAN 10. And look at this. We are not the root. Yeah, you can tell right away we are not the root device because we have a port in blocking state. Yeah, we have a port that's blocking, so this can't be the root because we know the root device would have all of its ports in a forwarding state. Yeah, they're all designated and forwarding. So distribution 1 isn't the root. Is distribution 2 the root device? Well, let's check. We're going to do a show spanning tree for VLAN 10. And aha, look at this. Everything is designated and everything is forwarding. And if that's not enough, up here we have this bridge is the root. Yeah, so we just found the root device. It's distribution 2. Well, we are going to change that, aren't we? We're going to go to distribution 1. And we're going to say in global configuration mode, spanning tree, VLAN 10, your priority will be quite low, 4096. That is going to be a lower priority than the default we can see up here, and we should be winning the spanning tree root bridge election now. Let's verify this, of course, with our show spanning tree VLAN 10, and this bridge is now root. Yep, and this bridge now has everything as designated ports and forwarding. And notice that happened very, very quickly, and one of the reasons that convergence happened so quickly is because we're running rapid spanning tree protocol. All right, well, that was our task for step 2. Let's take a look at step 3. It's to verify our configuration on distribution 1. Awesome, we already did that. Finally, step 4, we need to use the command spanning tree port fast on the ACC1 interfaces that connect to PCs. All right, well, the trickiest thing about this is just figuring out which of these interfaces connects to the PCs. And it looks to me like Fast Ethernet 0/1 and Fast Ethernet 0/2. But you know what? We better double check that. How about a show CDP neighbor? And this is going to tell us which of the interfaces are connecting upstream. Yep, look at that. It's distribution 1 and distribution 2 that are accessible via the Fast Ethernet 0/3 and 0/4 interfaces. So what that means is we are going to configure the port fast setting on 0/1 and 0/2. So interface Fast Ethernet 0/1. Oh, why don't I do this? Interface range Fast Ethernet 0/1 to 2. And so now we are in both of those interfaces configuration mode, and we're going to say spanning tree port fast. It gives us a warning. Hey, if you're doing this and you have a switch plugged in, you could create a routing loop. Yep, we know all about that. We are going to end and save. And I suppose we could do a verification. I could say show spanning tree for the interface Fast Ethernet 0/1, and unfortunately that doesn't give us enough detail. Can we go in there with some details? Yes, we can, and this port is in the port fast mode. So excellent. And if I go up and doctor this for the Fast Ethernet 0/2, this port is in the port fast mode. I'll save one more time and close that window, and I do believe we have gone through all of the necessary configurations that we need to make. It is worth noting that even though we're in a rapid spanning tree protocol environment, it is still recommended that you go to the ports that connect to your servers and PCs and things like that and turn on port fast. Yes. So port fast is still a recommendation. It's still a very important part of rapid spanning tree protocol. I find that a lot of students think, oh, well, no more need for port fast now that I'm RSTP, and that is dead wrong. Well, thank you so much for joining me. A fun lab. We had our hands held in this lab because it is the only lab in this chapter. But don't worry, as you know, there'll be some more really challenging review labs to come in the rest of our chapters. And oh my gosh, we never checked our results. My goodness. So let's go ahead and check the results and make sure that we got a 100% on this activity, which we did. Whew. Thanks again for joining me, and I hope to see you in the upcoming review labs.